Alright guys, today we're going to start chapter 3 or unit 3, section 3.1, Introduction to Matrices. So first of all, before we can work matrices, we need to know what they are and how to deal with them, so all the parts. So a matrix is a rectangular arrangement of numbers in rows and columns. And the plural for matrix is matrices. Okay. And they are typically enclosed in brackets. All right. The dimensions of a matrix are the number of rows by the number of columns. Now, please remember that rows go left to right, and columns go up and down. Okay, so let's look at this matrix given right here. How many rows do we have? Okay, so there are 2 rows and how many columns? 3 columns. So this matrix is a 2 by 3 matrix. Okay, a 2 by 3 matrix. The elements are the numbers in the matrix. So this matrix has 6 elements. 6, 2, -1, -2, 0, and 5 are all the elements of this matrix. Alright, so let's start with something easy. What are the dimensions of these matrices? So for this one, this has 1, 2, 3 rows and 1, 2, 3 columns. So this is a 3 by 3. This has 1 row and 4 columns. This has 3 rows and 1, 2, 3, 4, 5 columns. This one has 1, 2, 3, 4 rows and 1 column. This has 2 rows and 2 columns. Now when a matrix has the same number of rows and columns, we call that a square matrix because it's the same on both the rows and columns, and square means has the same measurements on each side. Alright, now equal matrices. Okay, equal matrices are two matrices that have the same dimensions and each element of one matrix is equal to the corresponding element of the other matrix. Okay, so let's look at these matrices and see if they're equal. Okay, so example 1. If I have the matrix that the first row is 1, 2, and the second row is 8, 5, is that equal to a matrix that the first row is 1, 8, and the second row is 2, 5? Now, while they have the same elements, they're not in the same locations. The 1 and the 5 are in the same locations, but they switched the 2 and the 8. So therefore, these two matrices are not equal. All right, let's look at another one. So the first row of this one is 6, 3. The second row is 0, 9. The third row is 1, 3. This matrix, the first row is 6, 0, 1. And the second row is 3, 9, 3. Okay, so these are not the same size because this has 3 rows, 2 columns, and this has 2 rows, 3 columns. Okay, they have to be identical. And the first row had 6, 3. The first row here had 6, 0, 1. So these are not equal matrices. Let's look at one more. So the first row is 5, 6, 0. Second row is 0, 7, 2. Third row is 3, 1, 4. Then over here, first row is 5, 6, 0. Second row is 0, 7, 2. And the third row is 3, 1, 4. These are identical. All the pieces match up. They're the same size. So these two are equal. Now, we can use the fact that we know that matrices are equal to solve for values x and y. So here's our first problem. And this one's going to take a little bit because I'm going to write notes over to the side. So in this one, the first row is 2x. The second row is 2x plus 3y. So this is a 2 by 1 matrix. And we're going to set that equal to y on the first row and 12 on the second row. All right, and they're telling us that these two things are equal. So, since the matrices are equal, the corresponding elements are equal. So we can go 2x equals y and 2x plus 3y equals 12. Okay? Now, over here to the side, I'm going to put a note that says this forms two linear equations. Okay? And if you think back to Math 1, it's what we call a system of equations. Now, if you will look here, you can see that it says that y equals 2x. So that means that we can take this 2x and plug it in everywhere we see a y in the other problem. When we take something and plug it in for something else, that's called substitution. So I'm going to put a note here so that way you can go back and look at your notes. And we're going to say solve using substitution. A letter must be by itself. So we're going to go y equals 2x, and then we're going to say plug the 2x in for y in the second equation. So what that means is we're going to take this 2x plus 3, take out the y, and plug in 2x. So 3 times 2x is 6x. 2x and 6x is 8x. 12 divided by 8, if you use your calculator, is going to give you 1.5. Okay? And if you want to use fractions, you can. So I'm going to put the fraction answer there too, which is 3/2. I'd prefer you not use mixed numbers, okay? But you can use fractions or decimals here. Okay? Then the last thing we need to do is figure out what y is. So the last step, now plug in 1.5 for x in the first equation. So we're going to do 2 times 1.5 equals y. Okay, so 2 times 1.5 is 3. So now we know that x is 1.5 and y is 3. Now when you find x and y, you usually write them as an ordered pair. So this would be 1.5, 3. But I also would take it this way. That would be fine as well. So if you need to pause that and get caught up there, that's perfectly fine. All right, we're going to do 2 more of these and then we'll do an application problem. Alrighty, problem 2. We have 3x plus y Then the second row is x minus 2y. Then we're going to have equals x plus 3, y minus 2. Okay, so remember we set the corresponding pieces equal to each other, so we have 3x plus y equals x plus 3. We have x minus 2y equals y minus 2. Now, we just have to get one of the letters by itself. So I'm just going to work with the first set of equations. And I'm going to get the y by itself. Okay, so I'm going to subtract this 3x over here. So y equals negative 2x plus 3. And I'm going to circle that with a pencil like I did just a minute ago. And we're going to plug that into x minus 2y equals y minus 2. Now pay attention here because it goes in for y, so we have to plug it in here and here. Okay, so we get one of the letters by itself, then we plug it into the other equation for that letter. Okay, so I'm actually going to use the black pen so I don't have so much green. So here we go. So we have x minus 2 times the negative 2x plus 3 equals, then we're going to plug in the negative 2x plus 3. Again, when I plug stuff in, I prefer to use parentheses, and that way I don't forget signs, and I don't forget to distribute signs or anything crazy like that. So here, I get x. When I distribute the negative 2, this becomes 4x minus 6. So that becomes 5x minus 6. Here, the parentheses aren't doing anything for me here. 3 minus 2 is 1. Now, we need to get the letters on the same side. So I'm going to move this 2x over and add it over here. So that becomes 7x minus 6 equals 1. Then I'm going to add the 6. So 7x equals 7. Divide by 7. So x equals 1. Now, remember, we plug, what color did I use there? Now we plug this back into the first equation. So x is 1. So we plug in a 1 here. We plug in a 1 here. So this becomes 3 plus y equals 4. Okay. Now, we move the 3 over by subtraction, and y is 1. So my answer x is 1, y is 1. And you could plug it into both of these, and that would give you equal matrices. So if you did it here, you get 3 plus 1 is 4. Plug it in here. 1 plus 3 is 4. So 4 and 4. Here, 1 minus negative 2 is negative 1. 1 minus negative 2 is negative 1. So this would be 4, negative 1, 4, negative 1. Done. All right. Last one. We have 2x, 3 and 3z on this row equals 5, 3y, and 9 on this row. So we set the pieces equal. 2x equals 5, 3 equals 3y, and 3z equals 9. And if you look at this, you can just solve these individually and find them. So x equals 2.5. Y equals 1. And z equals 3. So my answer is 2.5, 1, and 3. All right. Moving on. You're planning dinner and decide to call several pizza shops and get prices. Gina's Pizzeria charges $12.16 for a large one-topping pizza, $1.15 for a 2-liter of soda, and $4.05 for a family-size salad. Tony's Pizza charges $10.86 for a pizza, 89 cents for soda, and $3.89 for salad. Display this information as a 3x2 matrix. So they want 3 rows and 2 columns. So we have to figure out how we're going to set this up given the information. Well, we have 2 pizzerias. So we could put all Gina's prices here, and all of Tony's prices in the second column. Now, the items we had listed were a pizza, soda, and salad. Okay, so the pizza at Gina's was $12.16. Pizza at Tony's, $10.86. Soda, $1.15. Soda, 89 cents. Salad, $4.05. Salad, $3.89. And what you can do is matrices help you compare things. So the pizza's cheaper, the drink's cheaper, the salad's cheaper. So as long as it tastes good, Tony's is a much better deal for us. So matrices can be used for real life problems too. If you have any questions, please let me know. Thanks. Have a good day.